Hello, welcome to this lesson. In this video, we are going to learn about multiplication and total probability rules. So I have an example here, but before we solve this example, I want to explain to you what the multiplication and then the total probability rules are. Okay, so let's look at the multiplication rule. Okay, so we have already looked at the conditional probability rule, right? Where I said if you have, say, event A and B, where the probability of event B depends on that of event A, they are going to have the conditional probability of B, okay, giving A to be equal to the probability of A intersection B, okay, divided by the probability of what? A, right? Okay, so from here, I can rewrite this as the probability of A, okay, intersection B equals what? The probability of B, sorry, the probability of A multiplying what? The probability of what? B given what? A, right? What we have here is known as the multiplication rule, okay? So it's just another way of rewriting the conditional probability rule, right? And then, of course, you know that assuming the probability of A rather is dependent on B, then you're going to have the probability of what? A given B, okay, to be equal to the probability of what? A intersection B, right? And then all divided by the probability of what? B, right? So from this case also, you're going to have what? The probability of what? A intersection B to be equal to the probability of B, okay, multiplying the probability of what? A giving B as already, okay, right? So you see that this will be the case if A is dependent on what? B, right? But you see that for all these two formulas that I have here, we have A intersection B here, and then you have what? A intersection what? B here, right? So for this reason, I can say that the probability of A, okay, um, I consider the probability of A multiplying the probability of B, given A has already occurred, will be equal to the probability of B, okay, multiplying the probability of what? A given B has what? Already occurred, okay. This is known as the multiplication rule, okay. This is what is known as the multiplication rule. Okay, so now let's look at what the total probability rule is. So assuming I have a sample space, okay, I have a sample space here, and then I partition this sample space into event A and then event what? A prime, right? And then let's say I have another event B in this sample space, okay, where B will also be partitioned, okay, part of B will be in A and then part of B will be what? In A prime, right? So what will happen is that A and then A prime are mutually exclusive, right? What that means is that you're not going to find a common event in A and then A prime, okay, they are mutually exclusive. So what will happen is that if A is in if let's say event A is in A, you're not going to find A in what? A prime again. So they are mutually exclusive. Okay, so let's look at what will happen here. You see that B has also been splitted into what? Two parts, right? Okay, so in this case, if I want to find B, okay, if I want to find B, you are going to have part of B in A. So you are, over here, you are going to have what? B intersection what? A. And then here you are going to have what? B intersection what? A prime, right? So if you want to find B, okay, B will be equal to B intersection A, okay, union what? B intersection what? A prime, okay, that's what B will be. If you find B intersection A, okay, you know what? B intersection A prime, then we are going to get what? The event B. That's what this means, okay. All right, so let's say you want to find the probability of B. Then in that case, you're going to have the probability of B, okay, to be equal to the probability of what? B intersection A, okay, plus the probability of what B intersection what A prime. Okay, that's what the probability of B will be. Okay, so now let's look at what else we can do to this. Okay, so this is known as the total probability rule. Okay, what you have here is the total probability rule, but you are going to do another transformation to this formula here using the conditional probability rule. Okay, so we learned earlier on that if I have events B and A, right, the conditional probability of B occurring given A has already occurred would be what? The probability of what? A intersection B over the probability of what? A, right? So the same thing here. Let's take this one here. We want to find the probability of B, right? So we are going to say that the probability of B, okay, given A, okay, let me write this in a different color. So we can say that the probability of B given A has already occurred will be equal to the probability of what? A intersection B, right? Divided by what? The probability of what? A, right? So you can rewrite this as probability of what? A intersection B equals to the probability of what? B given A multiplying with the probability of what? A, right? So I've applied the conditional probability and then the multiplication rule here. Okay, so we are going to have what we have here. Okay, so let's look at the second probability also. So for that one also, we have the probability of B given A prime has occurred to be equal to the probability of what? A prime. Let me do it this way, because the probability of what? B intersection what? A prime over what? The probability of what? A prime, right? So making probability of B intersection A prime the subject, you're going to have what? The probability of what? B given A prime multiplying on the probability of what? A prime. Okay, this is what you are going to have. So you're going to do this substitution, okay, in the total probability formula that we have. Okay, so let's look at that. So you're going to have the probability of B, okay, to be equal to the probability of what? A intersection B or B intersection A, and then we know that to be what we have here. So we're going to have this to be what? The probability of B, okay, given A has already occurred times what? The probability of what? A, right, plus the probability of what? B intersection A prime, which is what we have there. That will be what? The probability of what? B, okay, given what? A prime has occurred multiplying the probability of what? A prime. Okay, so this is another way of rewriting this formula that we have here, which is the total probability rule. So this is also a total probability rule that you have written in a different form. Okay, so that's what the total probability rule is. Okay, so let me use another scenario to explain this. Okay, I think this is enough. Okay, there can be a situation whereby you will have the sample space being split into many sub events. Okay, you can have another sample space here where you're going to split this into 4 events. Okay, so you're going to have event E1, you're going to have E2 here, you're going to have E3 here, and then you're going to have what? E4 here, right? And then let's say you have another event B, okay, which cuts across all these events B here. So in this case, you're going to have B again to be equal to what? B intersection E1, okay, union B intersection E2, union B intersection E3, okay, union B intersection what? E4, right? So in this case also, the probability of B, okay, will be equal to the probability of what? B intersection E1 plus the probability of what? B intersection E2, okay, plus the probability of B intersection E3 plus the probability of B intersection what? E4, right? This is what you have. So from here you can come and apply the multiplication rule. Okay, let's look at that. So you can apply the multiplication rule here also. So in that case, you are going to have the probability of B to be equal to the probability of B given E1 has occurred, multiplying with the probability of what E1, right? Plus the probability of what B given what E2 has occurred, multiplying the probability of what E2, okay, plus the probability of B given E3 has already occurred times the probability of what E3, plus the probability of B, okay, given E4 has already occurred times the probability of what E4. Okay, so you can have a lot of sub events in the sample space. Okay, it depends on the question. So if you have something like that, just know how to apply the total probability rule. Okay, so now let's focus on the example that I have here. Okay, so let's look at this example that I have here. Okay, so the question says let F denote the event that the product fails, and then H denotes high level of what contamination. Find the probability of what F. So let's look at how you are going to solve this question. So actually this question deals with it's about semiconductor contamination. Okay, and then we are going to have different events for this question, where we have an event that there is high level of what contamination, and then an event that there is low level of what contamination. Then we have another event for what failure. Okay, so the semiconductors have been grouped into all these three events. Okay, so what I'll do is that I'll draw the sample space for this question. Okay, and then we apply the total probability rule to solve it. So what I'll do is I'll draw the sample space which we have here. So we have our sample space, and then you're going to have three events. The first event is the semiconductors that have high level of what contamination, right? So you're going to have those ones here. And then those that do not have high level of what contamination, those are going to be what H prime. Okay, so let me write H here and then H prime. Okay, so you're going to see that these two events are going to be mutually exclusive, because you can't have a semiconductor that have high level of what contamination and then do not have high level of what contamination at the same time. So we are going to see that H and H prime are mutually exclusive. So you're going to have another event F, okay, which is the semiconductor that will fail. So over here, you're going to have H intersection F, and you're going to have H prime intersection what F. So you're going to have those that have high level of what contamination and then at the same time have failed, and then those that do not have high level of what contamination and then at the same time have failed. So from here, to find the event F, you're going to have H, okay, event F will be equal to H intersection F union H prime intersection what F, right? So from here, we can have the probability of F to be equal to the probability of H intersection F, okay, plus the probability of H prime intersection what F. Okay, so rewriting this using the multiplication rule, we are going to have the probability of what F to be equal to the probability of what F given H, okay, multiplying the probability of what H, okay, plus the probability of what F given H prime times the probability of what H prime. Okay, so this is the formula that we are going to use to solve the question. So let's go back to the table. So from the table, we have the probability of level column here. Then we have the probability of what failure today. So from the probability of level, we're going to have the probability of what H, okay, the probability of what high contamination to be equal to 0.2, and then the probability of what not high, that one you're going to have that probability of what H prime to be equal to what 0.8. And then going to the probability of what failure column, you're going to have probability of what failure due to high level of what contamination, okay, to be equal to 0.1, okay, or the probability of what failure probability of failure given there is high level of what contamination to what 0.1, and also the probability of what failure given that there is low level of what contamination with what 0.005. Okay, so we have all we need to solve the question. So let's go back to the formula and then do the substitution. So probability of f will be equal to what probability of what f given h, which is 0.1, right, multiplying the probability of what h, which is what 0.2. Okay, so plus the probability of what f given h prime, that would be 0.005, multiplying the probability of what h prime, which is what 0.8. Okay, so let's simplify this and see what you're going to get. Multiplying 0.1 okay by 0.2 give us 0.02. We're going to have 0.02 here plus 0.005 multiplying 0.8. That gives us a value of 0.004. So let's add these two and see what you're going to get. So you have 0.02 plus 0.004. That gives us a value of 0.024. So the probability of failure will be what? 0.024.